Hello everyone. The title of this video is Translating English Sentences into Linear Inequalities. Alright, so in this video I'm just going to be doing 8 examples in which I'm giving a very simple English sentence and asked to translate it into a mathematical statement being a linear inequality. Right, so an inequality symbol will show up either is less than, is greater than, is less than or equal to, or is greater than or equal to. Now where I'm pulling these exercises from is from the website openstacks.org, from their Intermediate Algebra 2nd edition text. And this is from the exercises in section 2.5 on solving linear inequalities. And I'm working on problems 338 through 345. Now I've written these out. I'll be doing them on a separate paper, but in each of the exercises you're asked to translate into an inequality and solve said inequality. Then graph the solution on a number line and write the solution in interval notation. So 3 things here. Now I'm going to be calling these example 1 through example 8, right? So if you are following along, example 1 corresponds to exercise 338. Example 8 corresponds to exercise 345. Alright, so let's pull this up. So example 1, and in each of these again exercises the instructions are the same. Translate and solve translate to an inequality and solve it. Graph the solutions of this inequality on a number line and write the solutions in interval notation. Alright, so just going to write these things as I read them, right, as expressions pop out at me. And you're looking for key words here. So the first thing I notice as I read this is, 3 more than h. So what you're going to have is you're going to have a, just like any other inequality equation, you're going to have an expression before the verb. Alright, and the verb is, is no less than, is greater than, is less than or equal to, is at least, is at most, is more than, whatever. There's a statement before that will be represented by a mathematical expression before the verb, and then after the verb, and then the verb itself, the verbiage, the action words, those will be represented by an inequality symbol. Is less than, is greater than, is less than or equal to, is greater than or equal to. So 3 more than h. So I have this variable h. Now this expression just represents simply h. 3 more than h is, more than is plus 3. Right, here's h, and then if I add 3 to it, this expression is 3 more than h. For example, right, if it was 3 more than 10, you'd have 10 plus 3, 13. 13 is 3 more than 10. Right? So h plus 3 is 3 more than h. Now the verb, which usually will begin with some sort of form of to be, like is here. Is no less than 25. Now is no less than is not less than. Well, if you're not less than, that means you're greater than or equal to. Because really, when you're talking about numbers, you can either be less than something, equal to something, or greater than something. Well, if you're not less than that, that means you're either greater than or equal to. It's called the law of trichotomy. Right? You're either less than a number, equal to a number, or greater than a number. And if, again, one more time, if you're not less than 25, that means you're greater than 25 or you're equal to 25. So this is no less than, it's going to be is greater than or equal to. Right, that's where this is going. And then the other side is simply 25. All right, so here it is, the English sentence, pardon me, translated into mathematics. 3 more than h plus 3, is no less than, right, is greater than or equal to 25. So I've done the first part, translated. Now I solve, right? Remember, to solve an inequality, I'm going to get all the terms with my variable. I prefer it on the left side, and everything without the variable on the right. And this is a very simple one. All I need to do here is subtract the term of 3 here and do it to both sides. And the inequality will not flip because all I'm doing is subtraction. Right, the only time we're going to flip the inequality symbol around is if you multiply or divide by a negative number, or if you switch the expressions on the sides, switch sides. But for the most part, we're only going to be flipping is if we multiply or divide by a negative number. So now I have h on the left is greater than or equal to, and then 25 minus 3 is 22. So here's a description of all the solutions to this inequality. All the numbers I could replace h with in this sentence and have it be a true statement. Right? I could replace h with anything greater than 22 or 22 itself, right? Greater than or equal to. Let's test it out. How about 25? Right? 3 more than 25, that would be 28, is not less than 25. That's true. 28 is no less than 25. And so on. Right? So I've solved. Great. Now I want to make a graph. So there's a number line. Remember, we got 0 somewhere, and then positives to the right, negatives to the left. Positive 22 would be somewhere to the right of 0. And I'm marking off all the numbers greater than 22, right? So to the right of 22, right? 23, 24, 25, etc. So I marked that off with a little arrow to the right here. And then 22 itself is also a solution. So I indicate that with this rectangular bracket. Right? You either use a bracket or parentheses. Bracket means the number is a solution. Parentheses means it's not a solution. Now in other texts you might just see a closed point. So you could also see this. This is the same graph. These are the same graph here. Either one's fine. But the closed point, the dot above a number, means that it is a solution. And an open point, just a hole above a number, means that it is not a solution. Alright, so I've got the solutions to my statement, the graph of the solutions, and then I'm writing this same set of numbers in what's called interval notation. Interval notation for a set of solutions is just, you're always going left to right. Looking at the picture of solutions here, the number on the, where does it start on the left? It starts at the number 22. So I write 22, comma, and where does it end on the right? Well, it doesn't. It goes off to the right forever. So I indicate that by writing, positive infinity. Right? So from 22 to infinity. And then you cap these off with either a rectangular bracket if the number on the end is a solution, or a parenthesis if the number on the end is not a solution. Now we said already 22 is a solution here, so I'm going to put a rectangular bracket on the cap on 22. And infinity or negative infinity, either side infinity, infinity is not a number. Right? You can't plug in infinity for a variable. So it can't be a solution. So anytime you see infinity or negative infinity in this interval notation, you're capping it with a parenthesis. Right? And there's the interval notation describing all the numbers greater than or equal to 22. All right? All right, and like I said, I have 8 of these, some pretty simple statements, and we're going to translate them, rewrite the statement in mathematics as an inequality, solve that inequality, graph, and write interval notation. All right, second example. Same instructions. Okay. So that we have 6 more than k. 6 more than k. And then we have exceeds, right? There's the verb, right? Exceeds. and then 25. So one side, the symbol, and the other side is just going to be 25. Now 6 more than k is simple enough. Here's k, and then 6 more than k would be k plus 6. Very easy. So there's 6 more than k. Now exceeds means is more than, is greater than, larger than, exceeds. So I have 6 more than k, k plus 6, exceeds, or is greater than, 25. And there's the translation from English into math, right? From an English sentence into a linear inequality. And then very simple to solve this one as well. I would just simply, subtract 6 from both sides to get k alone on the left. So if k is greater than, still greater than, because all I did was subtract. Right? I didn't multiply or divide by a negative number. And then 25 minus 6 is 19. So you could replace the letter k with any number greater than 19, and this would be a true statement, right? 6 more than 19.5. Right, that'd be 25.5. That exceeds 25. Yes, it does. Replace k with 20, 21, a billion, and this statement will be true. Any number greater than 19 replaces k and would make that a true statement. And then the graph on the number line. Here's 0, 19 would be to the right of 0. And we're only pointing out the numbers greater than 19. Here are all the numbers greater than 19, right to the right of 19. But not including 19, right? 6 more than 19 is 25. It doesn't exceed 25. So to indicate that 19 is not a solution, I put a parenthesis here, or an open point. You might see in other books something like this with an open point. Now, I'm just going to use the parentheses or the brackets in the future. Right? So there's the graph, and then interval notation going left to right here. This picture of solutions, from the left to right goes from 19 to infinity. And 19 is not a solution, so parenthesis on that. Infinity is not a solution, parenthesis on infinities all the time. Okay, and there's your interval notation describing the same set. Okay. Number 3, example 3. So again, I got an expression to the left of the verb, 10 less than w is at least, there's your verb, right, and then 39 on the other side. 10 less than w. Now, people often confuse this. They'll say 10 minus w, but that's w less than 10. What you do is, here's w, and then 10 less than w would be w minus 10. And let's see if I can make that make sense with some numbers. If I asked you, what's 10 less than 17? You would say 7, right? That's 17 minus 10 is 10 less. So 10 less than w is w minus 10, right? Not the other way around. Please be careful with that. Is at least 39 means 39 or greater. Is at least means is greater than or equal to. So is greater than or equal to, that's is at least 39. So there's the English sentence, translated as a linear inequality. 10 less than w is at least 39. It is greater than or equal to 39, 39 or greater. And then very easily add 10 to both sides. I'm not even going to write that. Just if I add 10, I'll have w is greater than or equal to 49. And there's the variable alone on the left, number on the right. There's a description of all the numbers that I could replace w with to make this a true statement, all the solutions of this inequality. So I could replace w with any number greater than 49 or 49 itself. Then a number line, and here's 0, 49 would be to the right of 0 somewhere. all the numbers greater than 49 are to the right of 49. So I indicate that with some arrow, and then 49 itself is also a solution. So I put the rectangular bracket there, or again a closed point. Then the interval for this, you're going from left to right here, from 49 to positive infinity. 49 is a solution, so rectangular bracket. Right? And then always, parentheses on the infinities. There's the interval notation for that set of solutions. And so hopefully after the first few, you're seeing, hey, this ain't so bad, I'm hoping. All right, I mean, especially in this section 2.5 of the OpenStax Intermediate Algebra 2nd edition, they're not throwing crazy, complicated sentences at you. All right, the fourth example. It's pretty similar to the last one. So you see I've got 12 less than x. So remember, that's not 12 minus x, that's x minus 12. Right, you take what x is and do 12 less than that. Minus 12, subtract 12. Is no less than, well, we saw is no less than back in the first one. Is no less than means is greater than or equal to. Right? Because you're not less. Right? If you're not less than 21, then you're greater than or equal to 21. So no is no less than means greater than or equal to, and then 21 on the other side. And again, very easy to solve this one. To get x alone on the left here, I would just add 12. So we have x is greater than or equal to 21 plus 12 be 33. And there's a description of all the numbers I could replace x with in this statement and have it be true. X can be any number greater than 33 or equal to 33 itself. Go to a number line. 33 would be to the right of 0 somewhere, and all the numbers greater than 33 are to the right of 33, right? And 33 itself is also a solution, so again I indicate that with a rectangular bracket or a closed point. And then the interval, right, this is going from left to right here, from 33 to positive infinity, bracket on 33, parentheses on infinity. All right, example 5. So here's the, is no more than, there's the verb. So the statement before that will be the expression on the left side. So this is simply negative 5 times r. All right, negative 5 times r, negative 5r. Now, is no more than means is not more than, is not greater than. Now, if you're not greater than 95, that means you're less than or equal to. So is no more than means the same thing as is less than or equal to. Right, so we have negative 5 times r is no more than, right, is less than or equal to 95. And then we solve for r. Now, this one's a little trickier, because if I want r alone, I need to divide by negative 5 on both sides. And this is that case where we're dividing, if you multiply or divide both sides of an inequality by a negative number, that's when the direction of the inequality will change. So we're going to have to flip this inequality symbol here. Okay, so the left side I've got r. Now instead of is less than or equal to, right, is greater than or equal to. And then a positive divided by a negative will be a negative, and 5 goes into 95 19 times. So this is negative 19. And there's a description of all the solutions to this statement, right? All the numbers I could replace r with and have this statement be true. So r is any number greater than negative 19 or negative 19 itself. Here's the graph. Right, now negative 19 would be to the left of 0. And again, all the numbers greater than negative 19 are to the right of negative 19. including negative 19 here. So again, a rectangular bracket or a closed point on negative 19 there. The interval for this, left to right, going from negative 19 to the far right forever, right? So to positive infinity. Negative 19 is a solution, so again a rectangular bracket. Infinity is not a solution, it's not a number, always parentheses on the infinities. Okay, got 3 more, and again pretty simple statements, I feel. So here's number 6. So again, negative 2 times s, and then the verb is, right, is lower than is the verb here, and then 56. Well, this is simple, this left side, right? Negative 2 times s, well, it's very simply negative 2 times s. Negative 2s is lower than, is less than, right? Very easy translation there as well. Is less than 56. Alright, and then to solve for s, right, I would have to, this is multiplied by negative 2, so to undo that, divide by negative 2 on both sides. And just as the last example, right, you multiply or divide both sides of an inequality by a negative number. That changes the direction of the inequality. You're going to flip the symbol. So left side is s. This is less than becomes is greater than. And a positive divided by a negative is negative, and 56 divided by 2 is 28. Right, so there's a description of all the solutions, right? All the numbers I could replace s with and have this be a true statement. So s needs to be a number greater than negative 28. Number line, negative 28 would be to the left of 0. All the numbers greater than negative 28 are again to the right, but not negative 28 itself, right? So parentheses on the negative 28, not a bracket, or an open point. And then for the interval from left to right, we're going from, negative, this picture of the solutions is going from negative 28 to positive infinity. Negative 28 is not a solution, so parenthesis on that. Infinity is not a number, right? So parenthesis on that always. There's your interval notation. Wonderful. Example 7. So again, 19 less than b. We saw one like this before. Is at most is the verb here, and then negative 22. Well, 19 less than b, remember that's b minus 19, not the other way around. All right, let's take whatever b is and do 19 less than that, subtract 19 from b. So 19 less than b is b minus 19. Is at most negative 22 means that negative 22 is the largest it can be. That's the most it can be. So it's negative 22 or lower. Negative 22 or less. The is at most means is less than or equal to. Alright, so here you go. This is 19 less than b is at most, right, is less than or equal to, and then negative 22 on the other side. And a very simple solve here, just add 19 to get b alone. So b is, again, all I'm doing is adding, so the adding and subtracting doesn't change the symbol, doesn't flip it. And negative 22 plus 19 would be negative 3. Right, so here's a description of all the solutions to this statement. I can replace b with any number less than negative 3 or negative 3 itself, and this would be true. And here's a graph. Number line right here, 0, negative 3 would be to the left of 0. And all the numbers we're looking for, all the solutions are the numbers less than negative 3, so this time to the left, and including negative 3, right? So I'm putting a rectangular bracket opening that way, or a closed point. And there's a graph of the solutions. All right, and this time when I do interval, going left to right, there is no left end, so I indicate that by negative infinity, right? It tells me it's going to the left forever. So from negative infinity all the way to, the far right end of this piece is negative 3. And then as I mentioned before, all the infinities, negative infinity, positive infinity, those aren't numbers, so they can't be solutions. You put parentheses on those caps. And negative 3 is a solution. So again, the rectangular bracket. And make sure you're drawing these carefully and don't rush them, because if I find that people, when they rush these, sometimes accidentally make them too curvy, and then people confuse them with the parentheses. It should be a nice little 90-degree angles. Let people know, hey, negative 3 is a solution here. All right, and then I have one final example taken from that intermediate algebra second edition book, those exercises, and it's very similar to what we just saw. 15 less than a, that's take a and do 15 less, a minus 15. We saw is at least earlier. Is at least negative 7 means negative 7 is the lowest you can get. So your negative 7 or higher, negative 7 or greater, that's is greater than or equal to. Right? That's is at least is greater than or equal to. And then negative 7 on the other side. And again, another very simple solve. Just add 15 to both sides, and we get a is greater than or equal to negative 7 plus 15 would be positive 8. And here is a description of all the numbers that I could replace a with to make that a true statement, right? All the solutions of this inequality. A is all the numbers greater than 8 or equal to 8. Then on a number line, 8 is to the right of 0. All the numbers greater than 8 are to the right of 8, or 8 itself, right? So I include 8, put a rectangular bracket, opening in the direction of the other solutions, or a closed point if you want. And then the interval for this, from left to right, we're going from 8 to positive infinity, right? And 8 is a solution, right? So rectangular bracket on this, and then parentheses on infinities always, right? Wonderful. Okay, so again, some 8 pretty simple statements. And what I did was, I didn't cover every possible collection of words you're going to come across. I was only doing the exercises that were provided in that part of the section 2.5 exercises from the OpenStax Intermediate Algebra second edition book. Right, there are definitely other key words that you might come across when doing translations and word problems, but I'm just hoping watching me go over these few here, give you a rough idea as to how certain things are going to be translated. And I want you to just understand that you really got to pay attention and read carefully, make sure you understand what the English words mean. And the verb, usually it's going to be is, are, was, were, exceeds, belongs, whatever. Usually where the verb is located is where the equation symbol or inequality symbol will go, and then the stuff to the left of that you'll have to express, the stuff to the right of that you'll have to express as well, and then go about solving your problem. Alright, and hopefully watching me go over this stuff helps you out when you're looking at similar work. And thank you very much for, oh yeah, and by the way, I forgot to mention this at the top of the video, and I apologize if you've watched the whole thing. As with other videos I've put up, you should be seeing a timestamp for each of the examples in the description of the video, so that way you can bounce around and not have to watch the whole thing. Unfortunately, I didn't mention it till the end here, but if you want to go back and look at other examples more quickly, you don't have to keep scrolling back through. You can just click on the timestamp in the description. Alright, and thank you for watching.